Okay, all right. So today we'll look at aspects of access control and authorization mechanisms. Just a minute. Okay, these are the contents. I have taken contents from here. Okay, so have you heard any of these terms in your any time? I mean, in any course or any time? Did you hear about ACL? Access control list, right? ACL is very commonly used, right? Data structure. Yeah, your IT guy will know about ACL. Okay, if you read little bit about Linux, then you will come to know what ACLs are and what are the capability lists, right? Anyway, um, we will go quickly through it. Okay, so access control, so far you know what it is, right? We need to control the access of any process or anyone, any subject to an object or to number of objects, right? So object could be as simple as you know reading from a memory, okay, memory location, but a process cannot read anything that's available on RAM, right? So in your machine you have RAM and secondary memory, okay, and you have number of processes, right? Okay, what are you allowed to read? Okay, can you read the complete all memory locations in OS or in RAM? Okay, how can you separate some locations which P1 is reading uh, from something that P2 is reading? Both will have access to random access memory, but certain address space, within address space process can play. Okay, so or for example a process say P is wants to print a file on a printer. Okay, this process P could be your word processing like Microsoft Word. Is this process directly send file to a printer, or is it going through something? Or can anybody print? For example, printers are having nowadays Wi-Fi connection. Okay, and your friend comes in and then wants to print a document on printer. Can he or she do it? No. So there is some kind of access control mechanism is required. A printer by its as a process, any process which you create, say Microsoft Word, cannot directly print. It has got to go through OS. Okay. All right. So anything that we do that either that requires some kind of check. Okay, whether the process or person is allowed to do certain things or allowed to enter requires access control. For example, you go to movie theater, okay, or you want to watch a cinema or movie that has come in, and then you need some access control mechanism, which is ticket. Okay, all right. So the hundreds of examples are there which you'll see in daily life, right? uh, so basically access control has three aspects: authentication, authorization, and computer resources. Okay, all right. Just a minute. Okay, all right. So access control simply says who is allowed to access what. Okay. So basically access control to resources involves authentication and authorization. Authentication is that you present your identity card. You enter an office in organization, you present ID card, then you are allowed to do certain things. So based on ID card, you may be allowed to get into it. ID card might have expired, right? Or is somebody else ID card, so may or may not be allowed. If it's a valid ID card, then you will be allowed if second level check is not done. And then if you are allowed to enter, then you will be authorized to do certain things. You can go to a desk, do whatever you want, but you will not be allowed to get into server room or CEO's room or whatever, right? Okay. And this requires a policy and enforcement. Okay. So there has to be access control policy. All right. Uh, and then enforcement. So basically everyone is entering office. A security guard is entering, IT operator is entering, and also helpers are entering to go to cafeteria, and then finance department guys are entering, and but everyone has different authorization to do different tasks. For example, somebody who is a cleaner, okay, will not be allowed to enter certain places, or one who is serving in cafeteria will not be allowed to enter some other places, right? Or IT employees will not be allowed to enter some areas, right? So everyone has different roles to play, and these roles are assigned by policy, and based on the roles access rights are given. That's a normal process. Okay. uh, so however this requires complete mediation. It means that all the requests have got to go through a central place that we have studied in one of the classes, which is called reference monitor, and that's driven by policy. So access control example is nightclubs. While when you enter a nightclub, first thing they do, especially in US, not so in India, they check ID card whether you're a genuine person or not. Okay, and then they check. Then if you're allowed to get in based on whatever your ID card, then over 18 are allowed to get in. Over 21 are allowed to take alcoholic drinks, and if if your name is in VIP list, you are allowed to access VIP area. Okay, all right. And what are the enforcement mechanism? Walls, doors, locks, and so on. Okay, all right. Can we make it more complex? Yes. So instead of just anybody showing ID card and entering, one can always have tickets. If there is special event on a day, then you will be issued a ticket, and then again ticket can have name, or it could be anonymous, it can have date. Okay, what happens if you want to go out and come back again? Then we kind of hand stamp or bracelets are given. Okay. And we have seen that access control requires two important rules which we have studied earlier: least privilege and separation of duty. It means that each entity is granted minimum privilege necessary to perform a task, and second is separation of duty. Okay, now there must be some data structure to manage all this. It's called access control matrix. This is very common. Okay, now this is the reference model. So basically, subject could be a person or process, and then object could be anything, right? It could be access to, say, memory or file or some resource, say printer or whatever. Okay, and there is a reference monitor which will check your request. Okay, and then based on the policy, access is permitted or not permitted, and access is permitted to what? Okay, for example, access may not be permitted for object 1, but access is permitted only to use object 2. Okay, so this is a model. Now we can, so there is subject of, is also called subject object model. Uh, so there are set of subjects, set of objects. Objects would be memory, address, peripheral devices, and so on, right? And then access rights could be read, write, or execute. Okay, all right, just a minute. Okay, all right. So now we can have a data structures for this, and it's called access control matrix. And you can see this matrix has is it has subjects in column like S1, S2, S3. This could be, you can think of users, right, or processes. And no, sorry, rows are subjects and columns are objects. Okay, it means that now, say for example, object 1 could be printer, it could be memory space, it third object could be a file, and so on, right? And S1, S2, S3 could be process 1, process 2, and so on. So now, so the element in this matrix, like for subject I and object J, it will be Aij, and this Aij, when A is a matrix, Aij will give whether what kind of permission subject I has to use, or object J or object Oj. Okay, so we can so we have shown here in the bottom rights. So we can so in this matrix we can have all the subjects and all the objects, and then this matrix is kept somewhere here such that access rights can be given to different processes. Okay, so what's the issue with this one? What is the issue with this whole method? You've done data structure course, you will understand that metrics in general have certain problems, right? One problem is that what happens is sparse matrix. So most of the entries here are empty in this matrix, right? And this happens because not all processes or subjects want all the objects. Okay, so there is a lot of elements are empty. So what we can do is, and instead of having matrix, we can have either we can split this or represent this in this way, column wise or row wise. Okay, so basically when we, so correspondingly we say that access control list and capabilities. When we say access control list, what do we mean by that? So x axis are the subjects. It could be, for example, student 1, student 2, student 3, and so on, student n. And objects could be say printer 1, printer 2, file 1, file 2, and so on. Okay, so we say that when we say access control list, we'll say who all are, what all students can use P1, or this object. Okay, so we can create a list around that, right? Yeah, okay. uh, okay, other way of looking at it is that what all students, say what each student has capability. Say a student has capability to enter classroom or use printer or whatever, right? Or go to gym or whatever, right? So all these things, if we take row wise, then we can represent what each student is what rights each student has. Okay, column wise, what for each resource, for example, gym, what are the students who are allowed to get into gym? So it will contain that list. Okay, so which one of these will be more popular? It depends, right? It depends. If there are too many of these versus too many of these, you'll have to look at the efficiency. If the, number of resources are into 10,000 or something like that, and each will have just few students may want that, then putting it ACL wise is better. And there are only few students are there, and then putting it for each student, what are the capabilities or what all resources the user that student can use. The row wise representation is better, right? So we have access control list corresponding to an object which is shown in red, and then we have okay.
So why don't we use graphs for this?
Pardon?
Why don't we use graphs for this?
Why
So if
don't we
we pick
use
any node, like we
graphs?
can just take the index.
Yeah, graphs also you will have to see. You can use graphs also. What exactly is graph? It is showing. In fact, is a sequential. In a graph, you have to traverse a graph, right? For an object, you have to then kind of create linked lists. Is that right?
Yes, sir, but while interpreting the data, like if it is a graph, then it will be easy to get the data instead of iterating over every list, right?
Yeah. So, but what is the objective? For subject, you have to find out what, for you, for example, what all you can do, that you have to find out. So now you create a graph around what?
Which has a nodes has both subject and object. So
Subject and objects.
if we pick
Yeah.
anything, like we
So
will be getting
how?
the interconnectivity and we can find the entire list over there.
Yeah, you can do it, but look at the efficiency, and look at the efficiency. Look at what all you can achieve through that. And graph, and so basically what I mean, list is actually a kind of graph, right?
Yes, sir, it is a graph, but while computing and interpreting, graph has its own properties. Like, so I'm saying, like, instead of storing the data in list, if we directly use the graph data structure, then it will be easy. Then if it is a graph, then there won't be any sparse entries, right? If you pick a particular node and check the interconnectivity, then it might be a bit efficient, I guess so. I haven't, so I just thought, like, why won't we use that one?
can you hear me? Hello.
Yes, sir, you
Hello.
are audible.
Okay, I'm sorry. There was some disruption in WebEx service. Could be my internet connection. So I have internet connection, right? That's availability. Okay, let's. Okay. All right. So we discussed that on the capability list and ACL we can do following operations: add user, remove user, add object, remove object. Okay, these are the four means, and we can see uh, what works well in under certain conditions, right? So for ACL based systems, adding and removing user requires changes in ACL of existing object. So suppose somebody, say Mohan, goes out of university and he has access to various labs and places, then for each one of these objects of ACL corresponding to those objects, say lab 1 his name will be removed, lab 2 his name will be removed, and so on and so forth, right? So it will require certain number of operation. Now in case of capability based system, adding and removing object requires changes in capability list. So Mohan goes out, just delete that, all whatever access he has, just delete that. So it's very simple, right? Okay. um, okay, so ACL is good when there are fewer user centering operation like adding user, remove user, uh, changes, and so on. So very few. If there are many, then other one, uh, that's the capability is better. All right. So many applications like OpenStack object storage uses ACL and so on, right? So okay, so and we can see that access review, you need to review who all are allowed to have an access to an object. Say for example, somebody wants to do audit on who are allowed to get into a server room. Okay, so if you have capability, then it will be very difficult. You will have to look at capabilities of each student and see who has access to lab. However, if you have just for lab, if you have a list, okay, ACL, and it will say student 1, student X, and so on are allowed, then it's very simple to review it. Okay, revocation is removing the access, right? Okay. Um, so if for lab 1 if you want to remove say student 1, so it's very simple. All right. Small question as this yeah, just a question, right? Alice goes to a movie theater and purchases a ticket for her favorite movie. She is allowed to access the movie because she has the ticket. So ticket is more like what? Access control, entry, or capability? Anyone? You go to a movie and present ticket. The ticket represents what? What is the object here? Object is a movie theater. Okay, and you present a ticket. So basically, you're using ACL. It's not telling what are you are capable of. You are going to a movie, capable of going to buying a shoes and so on and so forth, right? It's not your capability. It's actually object here is a movie theater. Who all are allowed to get in? Who are all allowed? Those who have ticket. Okay. Now, access controls are various types. First is discretionary. It means that the owner of the process can give rights to other processes or other users. So a user owner can anybody else, right? For example, a owner of a lab can say that who all can use the lab. Okay. So a process can, a process, owner of process, if you understand the concept of process, then a process has an owner. Okay. Owner can give certain rights to other processes. It can grant the right access to other users, right? Okay. All right. So, so at a discrete you heard of set UID mechanism in Linux? Okay, just read about it. We'll possibly study that. The second is no discretionary is where the owner of something has rights to, has right to accesses to anybody he or she wants, or the process wants, right? But while policy based access control is based on certain policies, right? One a type is called mandatory access control. Okay, it's now is totally based on the policy, and policy has to be defined. So, example, this policy denies us full control over access to resources that they create. Unlike earlier case, if process has created a resource right over that, now we can create a policy whether the creator of the resource can be denied access rights of that, right? So this totally policy based, and one example is multi level security that's used in defense services. Okay, so for example, there are documents, so every object and subject. Okay, subject could be starting from whatever level, the soldier to up to journal, right? Various levels are defined. Okay, and we can say, for example, is unclassified, confidential, secret, and top secret, and these also correspond to files. Okay, let's assume these are the documents. Okay, and similar labeling exists also for personals, okay, or subjects. So each user and each document has security classifications, and users must be granted appropriate clearance before he or she can see the classified information. So for example, those confidential clearance are authorized to view confidential documents, and so on and so forth, right? So the one who has authorization for secret cannot see top secret document. Okay, so here the data flow rule is from lower level to higher level. So we'll look at the example. This is one of the very common model is called BLP model. Okay, so basically it says that data can flow between same levels, between secret and secret, and from lower level to higher level. So example is here, a process has label secret. Okay, a process wants to access documents that it has been labeled as a secret. Okay, among all levels it has a level secret, and there are various files of type. Say on top we have file A, then we have file B, C. The file A is topmost secret, is called top secret. secret, then secret, then confidential, and then unclassified. Now this process, the process on the one process here, which has label secret, can read files, file B, which is termed as secret, this one. Okay, it can also read this file, can also read. So this process with level secret can read file with secret. It can also read file with confidential, can also read file with unclassified, but it cannot read this top secret file. Now, however, this process can write top secret file. Okay, and this file A is not allowed to write. Okay, if there is another process with top secret level, that's not allowed to write file with lower level, right, which is like secret. Okay, all right. So it's actually, now does it sound counterintuitive? Like in a top journal, the say staff of army or staff of overall staff of defense services, or overall head of the defense services is not allowed to write policies for lower levels, or of lower levels, but allowed to read everything, while somebody at lower level is allowed to write files for higher levels. So it's write up and read down. Why does this happen? Any thought? Okay, well, I mean, just think about it. Why? Okay, this is just to avoid accidental write. See, if somebody at the top, say for example, some top level process can accidentally delete everything. Okay, what happens if the topmost person in defense services is corrupt, or something happens to him or her? Okay, all right. And the last type of access control is RBAC, role based access control, where we have defining the roles explicitly, right, and then access permissions are granted, and subjects can have multiple roles. Like you as a person can have multiple roles. You can be a student in a class, then you can also be in charge of sports, but you can also be in the drama club, or whatever, some art club, right? So you have different role, and you can be defined different access rights. Okay, and these access rights roles can change over time. Okay, this model in organizations, right? All right. Okay, so for example, individual can be defined various roles, and then for each role access rights are given. For role 1, a person can access only server 1. Okay, for role 2, the person who has a role 2 will have access rights over server 1 and server 2. Person with role 3 will have access rights over server 1, 2, 3, and so on. Okay, all right. And role could be anything. Role could be anything like developer, budget manager, director, help desk representative, and so on. And accordingly, permissions can be granted. Okay, and rules are active only for certain time. I mean, you can be head of, say, drama club only for a year. Then you have access rights over that for different objects only for a year. Okay, All right, so this is very common model that we use in organizations when we assign roles to individuals, right? An individual could be a developer, can also be a tester. If the person is a tester, he will have access right over whole code base. As a developer, he may have access right over whole code base. Or it could be also a person who will do code check-in, check-out. Then you will have all the access right over some tools to collect code from various places and create a build and so on, right? Okay, so there are various advantages here of RBAC, which you can read. Right, this is very simple. Okay, all right. So what we have covered today is that access control is necessary for granting access to various subjects, right? So, and this most essential thing in security, right? Because this is how securities or resources are kept safe from external intruders, right? Because only the processes or only the people who have provided proper access rights or access control rights like authentication and authorization. I mean, you can check in into bank account only if you have user ID, and you can present user ID and then you present uh, password, then you are authorized to do certain things in your account. Okay. Uh, so it's, as we have seen, it consists of authentication, authorization. It requires complete mediation. It requires also enforcement of policies, and we have seen access control matrix is not efficient. We can have ACL or capability list. Okay, it's called C list. There are two ways, and different systems use different ways. ACL is more popular because of the reasons we discussed. Then we have looked at the mandatory access control, and then we have seen, and within that we have studied BLP model, a multi-level model. It's also called multi-level model, and then role-based access control. Okay, that we use in organizations. Okay, all right. Any question?